Okay, so yesterday, just to kind of recap, and I kind of had to stop in the middle. Basically, this section is asking us to solve these by graphing, right? So graphing a circle on a TI 84 can be done, but you have to do it differently. So just to recap, in Desmos, we're trying to find a solution, and I'll read this. There's a radio station. It's bound by a circle. So the radio station is right here at the origin. There are towers there, and the broadcast reach is this far out, the red circle. And then there's a highway that passes right through it. And they're saying, well, where would you need to be? What highway exit would you need to be by for you to be within the broadcast range of this radio station? And they gave us some equations. This equation represents the broadcast signal, right? And this represents the highway. So the straight line is the highway. The broadcast signal is the circle. And so that was easy. We just plugged these equations into Desmos, gives you the answer. Now, the only thing that I had to do differently on the TI calculator is we had to split up the circle by solving for y, because your TI calculator only lets you, well, there's other ways to do it, but we, in high school and in an Algebra 2 class, we split it up into y equals a positive square root and y equals a negative square root. So the blue is the positive square root and the red is the negative. So we did all this stuff here, right? Based on, we did the positive square root, we did some algebra and solve for y basically, okay? So then, now that we kind of know, we believe that 43.632 is one solution and negative 43.128 is the other solution. Now we're going to do this algebraically. So to do this algebraically, I'm going to recopy it over here because this is a lot of stuff to write down. And I know it's going to be, we're going to have like, we're going to take some square roots, have to use a calculator and all that stuff. So to solve it algebraically, we're going to say the square root, and we have to do it with the positive root and the negative root. So I'm going to say 25 minus x squared, and I'm literally copying this from the last line on the previous slide, is equal to 1 over 20 plus 15x. So now the trick for this is that I need to this is not easy to do. I'm going to have to, I'm trying to think what's the, so I need to square both sides, right? Your textbook does it a slightly different way, but I just want to, it doesn't matter how you do it. We'll get the same answer. So in order to get rid of the square root, I got to do this. But whatever I do on one side, I got to do the other side. So now when I do this one, this is easy. I just get 2025 minus x squared. So when you square a square root, because they're inverse operations, you're just left with the base, right? Now over here, this is a little more complicated. So I can do this. I could say 1 over 20x plus 15. This is where it gets a little tricky. And I'm going to need to do my grid. Oh, it's drawn the funny lines again. I need to recalibrate that. And then I'm going to multiply that by 1 over 20x plus 15. So we could use our calculators to help us out with this if we want, right? So if I pull up my handy-dandy calculator and I hit math, and you should know how to do this by hand. You should. But we're trying to get problems done, and you guys are going to take the SAT. You got a minute a question, okay? I'm just going to plug it in the calculator. I'm going to say 1, it should be 1 over 20 times 1 over 20. Isn't that 1 over 20 squared? Yeah, it should be 1 over 400. So if you want to leave it as a fraction, I'm just going to say 1 over 400. And then we have these two x's. So x times x is x squared. Now we do the same thing with the 15. I think it's going to be 3/4 x, but let's see. I'm going to say, I'm going to hit math. I'm going to go to fraction. And I'm going to say 1 over 20 times, whoops, You got to hit that. I got to remember, hit the right cursor to get out from under the fraction times 15. So I'm multiplying 15 times 1 over 20x. So I'm going to do the coefficients, or the numbers, and it's 3/4. So this is a positive 3/4 x. This is essentially the same thing, 1 over 20x times 15. So this would be 3/4 x. It's positive. And then 15 times 15. Anybody know what that is off the top of your head? 15 squared? Is it 225? Yeah. So it's 225. Okay. So now, when I write this out, this is going to be 1 over 400 x squared plus 3/4 x. That's a bad 3/4 plus 3/4 x plus 225. So now I need to take 3/4 plus 3/4 and add them up. So I'm going to do that. I'm going to hit math. Going to enter in the fraction. And I'm going to say 3 divided by 4 plus, now I'm going to enter in the fraction again, 3 over 4, hit enter, and it's 3/2. So this whole thing becomes 1 over 400 times x plus 3/2 x plus 225. Okay? So I'm just going to, that's what this is expanded. So this whole thing, yes. Well, you're counting it, right? That's a great question. So the question is, what about the x's? Why is it just the x? So if I have a marker in my hand, right? I have one marker. And then I add 2 more markers. Do I have 3 markers squared or just 3 markers? Just 3 markers. Yeah. Does that make sense? Okay. Good question, though. It's a great question. So anyways, I'm going to say 1 over 400, this whole thing expands and becomes 1 over 400 x squared plus 3 over 2 times x plus 225. Whew. Well, this is actually a quadratic, right? So now, what is it that we don't like about this problem? Yeah, it's got a bunch of fractions in there. So I can get rid of the fractions by multiplying by the denominator. Usually, you start with the biggest denominator. So what I'm going to do, and we're going to have some really big numbers, and that's okay. I'm going to take this whole equation, see my little fraction here, and I'm going to multiply this by 400. So 400 times this, and so we're going to get some really big numbers, okay? Oh, I hate that. It triggers me every time. They intend for it to be helpful, but it's not helpful. So when I do that, okay. So I'm going to say 400 times 2,025. It's like 72,000 something. No, it's 81,000. So this becomes 81,000. Okay. Minus, what's 400 times x squared? Just 400x squared. And I got to do this to the whole equation. So I'm going to multiply it over here. 400 times 1 is 400. Divided by 400 is 1. 1 times x squared is just x squared. This one's going to be a little harder. What's 400 times 3? I'm saying it kind of fast, but let me do it. So if I'm going to multiply 400 times the numerator, which is 3. That gives me 1,200. Then I'm going to divide by the denominator, which is 2. Okay? Oh, wait. I got to do 1,200 divided by 2. 1,200 divided by 2. I forgot to hit the division symbol. So that's 600. Or you could simply just say 400 times and then put in the fraction, 3 over 2, and you'll get the same answer. which is 600. Okay. So this becomes a positive 600x, and then I wish I could slide that over. I can't. I gotta give myself some room here. Oh, got excited on the eraser. This is going to be a positive 600x. Let me fix this real quick. This is 3/2 x. And then lastly, I need to multiply 400 times 225. So 400 times 225. 400 times 225. 90,000. So that's plus 90,000. Is it 9,000 or 90,000? 90. Okay. And good thing I use a different color. So now I want to get all the x's to one side. Okay. So the first thing I'm going to do, because negative 400x squared is the lesser of the two x squareds, I'm going to add 400 x's to both sides, or 400x squared to both sides. Okay. Over here, this cancels. So I'm going to get 81,000 is equal to 400. Remember, this is a 1x squared. 401x squared plus 600x plus 90,000. Okay. Now, I want to set this equal to 0 because we're going to have to use the quadratic formula. So I'm going to say minus 81,000. I don't think it's divisible. Minus 81,000. Oh, I wrote down 80. I feel like I made a mistake somewhere. Yeah, it's supposed to be 810,000. Okay, that makes more sense. So I forgot a 0. Yeah. So this has got an extra 0. This has got an extra 0. This has got an extra 0. Thank you. I was looking at this and I was like, this is not right. Okay. So it wasn't 81,000. It was 810,000. 400 times. Let me see. That was a good catch. Yeah, it's 810,000, not 81,000. All right. So now I'm going to have 0 on the left-hand side. So this is 0 equals 401 x squared plus 600x. And then to find the last one, what I'm going to do is I'm going to, on my calculator, I'm going to say a lot of stuff to clear out. I'm never going to get that cleared out. So I'm going to say 90,000 minus 810,000. And I get 720,000. Okay, that looks better. So this is going to be negative 720,000. Okay. So remember, this looks like, and I can tell you right now, we're not going to try to factor this. These numbers are too big. They'll take you all day long. So remember, this looks like ax squared plus bx plus c is set equal to 0. So that means that my a term is equal to 401. My b term is equal to 600. And my c term is equal to negative 720,000. I did it again. 720,000, correct? Yeah. You guys got to pay attention, man. So knowing that, I can use a quadratic formula, which means that x is going to be equal to negative b plus or minus the square root of b squared minus 4 times ac all over 2a. In other words, that's going to equal negative b, which is negative 600, plus or minus the square root of 600 squared minus 4 times A is 401, times C, which is negative 720,000, all over 2 times A, which would be 2 times 401. Okay? All right. So now, the next line, I'm going to try to do this step by step. I've got negative 600 plus or minus. Okay? Your calculator can do the discriminant all in one swoop, right? So what is the discriminant? The discriminant is all this stuff. And I can even put it in the square root. I just have to make sure I put it in correctly. Okay? So I'm gonna take my calculator. Let me move it over here so we can see what we're doing. Oh, I hate that. All right. So I'm going to say the square root. So I'm going to go slow so you guys can do it with me. You should have a calculator in your hand. I know you're trying to hurry up and write stuff down. I'll give you guys a second to jot that down real quick. Do I need to move this out of the way? Do you guys have this much written down yet? Yeah. Okay. So now I'm going to say the square root. So second, the square root symbol. I'm going to say 600 squared minus 4 times, and you could do times, or you could literally put it in the way that I have it written. 4 parentheses 401, another set of parentheses 720,000, close your parentheses. Okay? You could literally put it exactly how I have it written. Oh, you know what I forgot though? The negative. So I'm going to insert, and it has to be a negative. So if you plug all this in, right, and you get an error message and it says syntax error, that means you put a minus sign when you should have put a negative, or vice versa. Okay? So this has to be subtracting 4, but this is a negative 720,000. So when I hit enter, whoa, that's a big number, isn't it? So that whole thing becomes 3,988. I'm going to move that to my other screen so I can see it as I write it down. 39, or no, I wrote it down wrong again still. It's 33,988.82169 all over. What's 2 times 401? 808. Okay? Now, you can do this in your calculator, but you have to do it 2 ways. You have to say x is equal to negative 600 plus, Yeah, you're right. It's 802. I don't know what's wrong with me today. I'm like making all kinds of mistakes. Good thing you're here. I'd catch these later because I know the answer is going to be 43 and negative 43 roughly, right? So if I made a mistake and I did all this math and I got a different answer, I'd know, yeah, you kind of messed up. So I'm going to do plus 33,988.861. Oh, there's a 2. See what I mean? 9 all over 802. And then, or x equals negative 600 minus 33,988.82169 all over 802. Oh, it's 169. Yeah, I screwed that up. I think I just get, it's getting towards the end of the school year and I get tired. See, I make mistakes too. All right, so now I could do this in my calculator. Okay, so I'm going to do this one first. Oh, that's frustrating. All right, So I can do this whole thing in one step. So if I go to, I want it to be a decimal. All right. So I'm going to put the numerator in parentheses. So I'm going to say negative 600 plus 33,988.82169, close parentheses. That's the numerator. That's all the stuff in the numerator. And then I'm going to divide by 802. Okay. Guess what it is? 41.63. Wait, was that one of our answers on the graph? Let's see. 41.63, right? I said 43 earlier, but see how that works? So let's go back. Let's write that in here. And if you round that, it is 41.632, right? So over here, I've got x is 41.6. What was it? 632. Now I got to do this again, but the only thing I'm going to do is change this plus symbol. So now here's a neat trick. If you hit second enter, it just copies and pastes the thing above. And I'm going to change this plus sign to a negative sign. So I use my cursor to go over here, and if I put a negative sign, it just, or not a negative sign, subtraction or minus sign. If I plug that in there, there's the other number, negative 43.128. So negative 43. Okay. And that's it. Now that's a really hard question. It's not hard, tedious. We did a lot of calculating, and if we made one mistake, we'd get the wrong answer. And so as you can see, Mr. Adams, I'm a math teacher. I've been teaching math a long time. I'm a little tired. Haven't had all my coffee. Right? I made some simple mistakes. That's why I like for you guys to use the graphing calculators, because when you take the SAT, we had the answer immediately by graphing it, right? I'm teaching you how to solve it algebraically and by graphing it. If you were to take the SAT, would you do all this algebra and get the answer in 1 minute? Or could you just graph it and get the answer? Just graph it. You need to know both. I'm teaching you both. I'm going to give you a test on both. But if you take the SAT, just graph it. Find the intersection and you're good to go. Also, I do research in the summertime. When we do research, we don't have the answers in the back of the book. So I do a lot of the same thing. I do a bunch of algebra and math and calculate things by hand. And then I go, what's a quick, easy way to see if I'm right? A lot of times it's just graphing the data. So if you're doing research, you graph the data, you look for the intersections. When you find the intersections, that's the optimum situation usually, or what you're looking for, or it creates a boundary. Okay. Any questions on this one? Thumbs up, thumbs down. How do you feel about this? Yeah, thumbs up on how to do it, right? But thumbs down, like, I'm going to make a mistake.